let's talk about chaos engineering itself. What is it? So this is a definition. Good to remember because it might come up on the quiz. So chaos engineering is the discipline of experimenting on a distributed system in order to build confidence in the system's ability to withstand turbulent conditions. So some key points in there, right? It's not a random approach. It's not an ad hoc approach. It's a very disciplined approach of setting up formal, almost scientific experiments where you have a hypothesis and a plan, and then you run an experiment. You know what you're going to look for and gather the information and figure out what you're going to do afterwards. So it's a true, scientific experiment. Exactly. Now, what are you doing that on your system, which are typically distributed systems these days? Why are you doing it? Because you want to figure out how the systems can fail and what you might be able to do to prevent them from failing if they were to happen in the real world. So you're anticipating and working proactively to look for potential issues and then take care of them before they actually occur. Just some background around chaos engineering. Netflix is credited with being kind of the founder of chaos engineering practices. They used it to scale their site reliability engineering practices some years ago. Netflix spends a lot of worry about making sure that their environments are reliable. They have streaming services available in most of the countries in the world, actually. I think it's 160 countries or something like that. So definitely they don't, want to have to spend a lot of time running into different problems. They need to anticipate them and avoid them in the first place if possible. Their most common reason for driving to chaos was the complexity of migrating to the cloud. They use Amazon Cloud in particular. So they've anticipated by now many possible challenges if the cloud services have a problem. Netflix, for the most part, has already figured out how to detect those problems and how to mitigate against the concerns when they occur. Netflix developed, actually it's a series of tools. In fact, Chaos Monkey is only one of them. There's a series of tools that are considered the Chaos Monkey tools. They're actually, I think the formal name is Simian Army. Simian meaning the genre of animals that are monkeys. So Netflix is the originator of those, and they're available open source, by the way. One word of caution, they're only really used and applied to AWS cloud, because that's what Netflix uses. But they also can provide a good model for either creating your own Chaos Monkey tools, as a lot of folks have done, or just getting good practices. And of course, if you use AWS, then they're directly applicable. Chaos engineering, it's kind of a myth to say chaos engineering is about breaking things. You're not trying to break things, obviously. That would be a bad thing. What you are trying to do is anticipate problems so you don't have failures happening, during production usage of a service. In general, it's to help you generate knowledge about failure modes of a system. And the failure mode should be derived from a real world application, not just made up. So they're carefully designed experiments. It's okay to start small. Certainly you wouldn't want to start by just trying in production, tearing down half your system and see what happens, take down a whole zone or something without ever preparing for that. That would be kind of dumb. So you would usually start with a relatively small segment of experimentation and build up to that. You would usually start in a non-production environment and make sure you have a solution for whatever problem you're experimenting with, and then try it in production before you declare you've got something that's going to work in production and move on to the next one. In general, you're trying to minimize the blast radius, or the area of your service. If you think about a service, it's kind of a map of of systems, a network of systems. You don't want a problem in one area to cascade into causing a much bigger problem across the whole network of systems. So you want to contain the problem to, a small blast radius, and then just recover that area and isolate it while you fix it. So that's one of the goals, or at least one of the tactics with chaos engineering, is to try to figure out how can you contain a problem if it does occur, and what are you going to do about it and recover quickly. You also can have a strategy to have an emergency stop. If you run into a problem that you don't have a mitigation for, you want to be able to stop and then roll back. Maybe you've got some data corruption or something. Make sure you've got copies of the good data that you can roll back to. There are many. These are just some example, good practices. There's a lot of documentation and books written around chaos engineering discipline now. This is an example of Courtney Nash's chaos engineering prerequisites. Okay, so sometimes to understand what something is good to think about what it isn't, just to put it in scope. So it's not about breaking things in production. I think we just said that. You certainly are going to try your experiment in production before you declare a success, but you don't start that way. You usually start trying in non-production environments first. It's certainly not about injecting random chaos experiments into the system and seeing what happens. That wouldn't be a good idea. You'll have to start in a controlled environment with the ability to turn off experiments right away if things go badly. And you want to be able to understand, how is your service behaving? Not just does it work or not functionally, but performance-wise, is it degrading slowly? Those are things you want to keep an eye on while you're doing these experiments. Some problems have kind of a creep to them, and you won't notice functionally that there's a problem for a while until everything reaches some threshold of choke or something. So these are some practices that you could play with as part of chaos engineering, or build into your experiments. Maybe stop Docker service. Try to do an attack on yourself, overloading part of your system with excess traffic or something. Let's call it a DDoS attack. Adding delay to your network, check for resiliency. Maybe burn down CPU time, or available CPU, by adding some load or stress to the CPU and see what happens. Disaster recovery, where you periodically switch over sites. Test for that. That's usually a DR requirement in a lot of audits, that you do at least an annual DR. So this is an example of what you might do as part of a chaos experiment as well, maybe much more frequently than annually. Fill up storage and see the system behavior. That's another way to run an experiment. Detach storage and volumes on the cloud. Use traffic shaping to introduce network packet loss and network packet corruption. So you can maybe put in some traffic tools to help do that on different links in the network service. Maybe kill some services and check for graceful restore. So these are just examples. And again, the Chaos Monkey tools, some of them are designed to help you do these types of things, and many other things as well. These are just some examples of what you might do during a chaos engineering experiment. Okay, the Chaos Monkey story, they're basically saying Netflix does run their tests, their chaos experiments during business hours. But again, you don't start that way. Usually we'll build the experiment in non-production first. I think this was already stated before. Netflix started this idea when they were going through a cloud transformation to AWS. It's a way of putting well-defined problems in front of engineers in sort of a scientific experiment. We already said this is an idea example. You can maybe terminate VMs. So you don't have to have Chaos Monkey tools to do a lot of these experiments, but they definitely help. There's other benefits in the way that they operate in this mode, and the way that you can turn them on or off, or the way they gather information and so on. We're not going to go through the details of that, but there is an exercise here where you can get a look at Gremlin as a chaos type of tool. So not everybody, I shouldn't say that. For sure, it's not everybody. But chaos engineering is being used as a discipline in many well-known organizations. This is certainly not an exhaustive list. Of course, Netflix, but there are banks and other critical service companies, credit card companies, finance, um, Uber, a lot of different types of companies, tool companies. Whenever I've been working with a client on SRE transformation, certainly the pillar of anti-fragility is something we consider in the transformation roadmap. Chaos engineering is part of the pillar of anti-fragility. And I've worked with plenty of firms, and it's usually not the first thing you do during the transformation, but it's something that comes up at least midway through the transformation journey. You first of all want to put in place things like your SLOs. So if you do have a problem, you can keep an eye on your air budgets and that's certainly, even though it's not mentioned in this module, is very helpful to have the SLOs in place while you're doing these experiments and use that to reflect on and understand how the SLOs will be affected during different kinds of outages, failures.